Hi, today we're going to be looking at writing chemical formula and chemical equations. As we've discussed previously, this is part of the additional content and will not be examined in the examination. So far we've been looking at writing word equations. This is one step further and using our knowledge of the symbols and writing chemical formula as one part of the extension to taking that one step further again and writing chemical equations. So to do this, we need to look at how to write chemical formula. So just to recap some things from earlier on in this unit. Atoms form ions, and this happens when they either lose or gain electrons. Now in the case of metals will lose their electrons. So for example, sodium has 1 electron in its outer shell. It is easier for it to give away 1 electron than to gain 7. Non-metal atoms will gain electrons. So chlorine, it's easier for it to gain 1 electron than it is to give away 7. Now valency is the name given to the number of electrons that are in its outside shell and whether it gains or loses electrons to fill that outer shell. So it's the charge possessed by that ion. So if electrons are lost, our valency will be positive, and if electrons are gained, the valency will be negative. So we've used the word ion, and what is an ion? An ion is an atom or a molecule that has an electric charge, and that charge comes about due to the loss or gain of an electron. So as we talked about right at the beginning when we looked at the periodic table, group 1 has a +1 charge, group 2 a +2 charge, 3 +3. Group 4 can have a +4 or a -4. What we're wanting is a full outer shell with 8 electrons. When we're in group 4, it can either gain 4 or lose 4, and therefore it has a + or -4. Group 5 has a -3 charge because it's going to take on 3 electrons, so it's gaining 3 extra negative charges, giving it a -3 charge. Group 6, -2. Group 7, -1. Polyatomic ions are other types of ions that you were introduced to earlier as well, and that is a charged species composed of 2 or more atoms. So you will have seen these already in the form of sulfate, SO4. It has an overall charge of 2-. Carbonate, CO3, also 2-. Nitrate, NO3, has a 1- charge. OH has a -1 charge as well. So how do we go about writing ionic formula for our compounds? Well, first of all, we need to know what an ionic compound is. And an ionic compound is formed when a metal bonds with a non-metal. And what's actually happening is there is a transfer of electrons from the metal to the non-metal. And when we want to write these names, there's a couple of rules that we need to follow. First of all, the metal's written first. And the non-metal, any an ide or a polyatomic ion, is written second. So the first step we have to do is identify the elements that are in the compound. We get that usually from the name. Then write them in ion form. Now we always have the total charge on a compound as being 0. So what we're trying to do is balance the charges, and the easiest way to do this is through the drop and swap method. So let's have a look at an example. Sodium chloride. First step was identify the elements. So we've got sodium and we've got chlorine. The charges, sodium is a +1, chlorine is a -1. Now we want an overall charge to be 0, so we want the balance of the charges. In this case, it is already balanced in that we've got a 1 positive and a 1 negative balancing out and becoming a 0 charge. However, this can also be done by the drop and swap method. So if we look over here, we have a +1 charge. We drop and swap to the other side. So this would become a 1 on this side. Here we drop and swap, and it comes over here a 1. So I've got Na1, Cl1. But we don't need to record the 1s, so we just leave it as NaCl. Let's have a look at another example. Magnesium chloride. So the first step, identify the elements. I've got magnesium and chlorine. Now let's have a look at the charges. For magnesium, magnesium has a charge of 2+, Chlorine has a charge of 1 minus. Again, our charges need to be 0. So I really need 2 negatives to balance the 1 positive. So in this case, I'm going to need 2 chlorines for every 1 magnesium. But it is much simpler to do just by using the drop and swap. So this 2 drops and comes down to the opposite side, and this 1 drops and comes to the opposite side. So here, magnesium 1, we don't record it when it's 1, Cl2. We'll practice many of these in class. See you then.